Hello, my name is Lene Stipulkowski, and today we will be doing a direct shear test on two different types of sand. This test can be done almost anywhere using very few materials. Direct shear tests are done in order to predict the friction angle of the soil that we are measuring. The friction angle gives us insight into how much strength is in our soil. It also gives us insight into how much the soil can bear before it experiences failure. With that, let's get started. In order to perform this test, you will want to use two different types of sand. I have both a fine grain sand and a coarse grain sand here. You will also need a plastic ring. This ring has an inside diameter of about 2 inches. You will need one spring scale. I have two, just in case the force that I need exceeds 1,000 grams or 10 newtons. This spring scale goes all the way up to 20 newtons. You will also need sandpaper, some regular printer paper. I have a few pieces, but you only need one. And then you will need weights that fit inside your ring. You also want a rubber band or rope or hair elastic will work. And then a little piece of cardboard that also fits inside your ring. Before conducting this experiment, you will want to know the weight of the weights that you are using. If you know the weight of your weights, then great, no worries. If you don't, then you'll want to measure the weight of the weights using your spring scales. You also will want to make sure that your spring scale is calibrated before, so that means you'll want the top of the blue part to line up with your top line that represents 0. And then you will also want a plastic shopping bag. So the first step is to put your first weight in the plastic shopping bag and then hang this from your spring scale. And I am getting a weight of about 130 grams or 1.3 newtons, give or take. I then am going to take my second weight and put it in my grocery bag and weigh that. Both of my weights are about the same, so it'll give me hopefully close to double the first weight. However, if you just have one weight that's double your first weight, you can do that. Ideally, you're looking for a weight that's twice as much as your first weight. So if you have two of the same weights, then you can use both at the same time. Or if you have a weight that's twice the size of your first weight, then you can use that too. Both the weights, I'm getting an approximate value of 260 grams or 2.6 newtons. So double the initial weight. Now that I know what my weights are, I'm going to make sure I write that down so that I don't forget it. And that will be our normal force. Now that we have our measurements, we can just go ahead and use this paper. And we want to take our rubber band or string or whatever we're using and wrap it around the ring. We then want to take our sandpaper and lay it across our piece of paper, overlapping them just a little bit. And we want to spread a thin layer of sand on the sandpaper. We want the thin layer of sand to be a little bit bigger than the diameter of our ring. Next, we want to loop our spring scale through our rubber band. I'm going to be measuring in newtons. You can measure in grams if you'd like. Whatever you're measuring, make sure that that's what's facing up so that you can easily read it. I'm going to then lay the ring on top of the thin sand layer that I just created. And then I'm going to use more sand, I'm doing the coarse sand at first, to fill up the ring about halfway full. Then take your piece of cardboard and flatten out the sand so that it creates just a flat layer in the ring. Next, leaving your cardboard in there, take your first weight and place it on top of your cardboard. Then double check that your spring scale is calibrated so the blue plate lines up with your 0. And then while holding the spring scale in place and your regular piece of paper, use your other hand to pull on the sandpaper away from your spring scale. While doing this, make sure you are checking the spring scale to observe how much force is taken in order to move the sandpaper but leave the ring in place. So at first the ring is going to move with the sandpaper, but eventually it will pull back towards the spring scale. So really just try to keep an eye on the approximate measurements that it takes in order for the ring to move. So I got answers that bounce back and forth between 1, 1.2, and 1.4 newtons. So I'm going to give it an average And this is our horizontal force. So Fx1c, because this is our coarse grained soil, is going to equal 1.2 newtons. Now we want to repeat the same process but apply double the amount of normal force. Okay, so I've reset this up. Now I'm going to take my cardboard and make sure that it's fairly flat and even all the way around. Then I'm going to take this weight and apply both of them to the sand. And then I am going to again hold my spring scale in place and move the sandpaper, all while observing the measurement on the spring scale. So I noticed it move at about 2 to 2.2 newtons. So we'll give it an average of 2.1 newtons. So Fx2c equals 2.1 newtons. I'm not going to run this on both sands because I want you all to do it on your own. However, you'll do the exact same procedure, but instead of using the coarse grained sand, use the fine grained sand. So spread a thin layer, lay your ring on top of it, fill it up about halfway. Using your cardboard, flatten it, and then add your weights and measure it using the spring scale. Do it with one weight and then again with your heavier weights. Next, you will want to calculate your stress. So your normal stress, which is going to be your normal force over the area of your circle or of your ring. So that's going to be your inner diameter. So we know that equals pi d squared over 4. And then you'll also want to calculate your shear stress, which is going to be Fx over your diameter times the height of your ring. With that, you can then graph your shear stress and your normal stress, and you should get a line for your coarse grained soil and a line for your fine grained soil. And then from there, you can measure the friction angle of each. Good luck with everything!